Hello everyone, I am Shankar Mane from Annasab Dange College of Engineering and Technology, Asta, Department of Aeronautical Engineering. Today I will discuss about the ISU activity of Advanced Propulsion System. Today my topic is Electrostatic Thruster under the guidance of Professor Yuvraj. First we will discuss about what is the electric thruster. Electric propulsion is a class of space propulsion which makes use of electric power to accelerate a propellant by different possible electrical or magnetic means the use of electric power enhanced to propulsive performance of electric propulsion thruster compared with conventional chemical thruster. Unlike chemical system, electric propulsion requires very little mass to accelerate the spacecraft. The propellant is ejected up to 20 times faster than the classical chemical thruster, and therefore the overall system is many times more mass efficient. Now the classification of electric thruster. Electric thruster is classified into three categories: electrothermal thruster, electrostatic thruster, plasma electromagnetic thruster. In electrothermal thruster, we have two categories: arc jet thruster, electrothermal thruster. In electrostatic thruster, coiled thruster and ion thruster. In plasma electromagnetic thruster, we have three categories: pulse thruster, Hall effect thruster, and high current thruster. Now coming on to our main topic, what is electrostatic thruster? Electrostatic propulsion thruster rely upon electric field for accelerating and expelling ion to produce thrust and propel the spacecraft. The production of ion acceleration is achieved through several differing means, including the conventional electron bombardment method or electron cyclotron resonance method, which electrically charged atom from onboard fuel supply. This fuel supply is inert gas, often xenon or krypton, which is injected in the ionization chamber, then expelled for propulsion. Electrostatic thruster provide relatively large ISP value, ranging from 1000 to approximately 10,000, and also have relatively high efficiency ranging between 55% to 98%, while electrostatic thruster produce minimal thruster relative to alternative propulsion method. The various implementation of this technology provide advantages not offered by the propulsion method. In electrostatic thruster, there are two types. We will give briefly about the one type. This is a ion thruster. Ion thruster are being designed for a wide variety of mission for keeping communication of satellite in the proper position. To propelling the spacecraft throughout our solar system, this thruster have high specific impulse ratio of thrust to the rate of propellant consumption. So they require significantly less propellant for a given mission than would be needed with the chemical propulsion. Ion propulsion is even considered to be mission enabling for some cases where sufficient chemical propellant cannot be carried on the spacecraft to accomplish the desired mission. Now we will see how does an ion thruster work. An ion thruster ionization propellant by adding or removing electron to produce ion. Most thruster ionization propellant by electron bombardment. A high energy electron coiled with the propellant atom, releasing electron from propellant atom and resulting in positively charged ion. The gas produced consists of positive ion and negative electron in proportion that result is no overall electric charge. This is called as plasma. Plasma has some of the properties of a gas, but it affected by the electric and magnetic field. Common examples are light and substance inside the fluorescent light bulbs. The most common propellant are used in ion propulsion is xenon, which is easily ionized and has a high atomic mass. Thus, generation and desirable level of thrust. When ion accelerate, it also is inert and has a high storage density. Therefore, it will be suited for storing on spacecraft. In most ion thruster, electrons are generated with the discharge hollow cathode by a process called as thermonic emission. Electron produced by discharge cathode and attracted to the discharge chamber wall, which are charged to high positive potential by the voltage applied by the thruster discharge power supply. Neutral propellant is injected into the discharge chamber where the electron bombardment the propellant to produce positively charged ion and release more electron. High strength magnetic prevent the electron from freely reaching and discharge channel wall. This lengthens the time that electron reside in the discharge chamber and increase the probability of an ionizing event. This positively charged ion migrate toward the grid that contain thousands of very physically aligned holes. At the aft end of the ion thruster, the first grid is positively charged electron. A very high positive voltage is applied to the screen grid, but this is configured to force the discharge plasma to reside at high voltage. As ion pass between a grid, they are accelerated toward the negatively charged electron to very high speed, that is up to 90,000 mega mph. Now we will see the past ion propulsion. The NASA Glenn Research Center has been a leader in ion propulsion technology development since in late 1915. It is the first test in space. The Space Electric Rocket Test 1, flying on July 20, 1964. From 1998 to 2001, the NASA Solar Technology Application Readiness Ion Propulsion System enabled the Deep Space One mission. The first spacecraft propelled primarily by ion propulsion to travel over 163 million miles and make flybys of the asteroid Braille and Comet Braille. In current ion propulsion, ion thruster based on a NASA design are now being used to keep over 100 geosynchronous Earth orbit communication satellite in their desired location. And 3 NSTAR ion thruster that utilize Glenn developed technology are enabling the Dawn spacecraft, launched in 2007, to travel deep into our solar system. Dawn is the first spacecraft to orbit two objects in the asteroid belt between Mars and Jupiter. Now see the advantages of ion thruster. Ion propulsion could be used for a manned mission to Mars. Ion propulsion make efficient use of the onboard fuel by accelerating it to a velocity 10 times than the chemical rocket. The ion propulsion system, although high efficient, is very gentle in its thrust. Less expensive launch vehicle is required when compared to the chemical propulsion. Less amount of propellant carrying tank, which is reduced weight of the spacecraft. With xenon, it is possible to reduce the propellant mass on board a spacecraft by up to 90%. Now see the disadvantages of ion thruster. First, unlike a chemical propulsion system, ion propulsion produces gentle amount of thrust but for a long duration. Second, ion propulsion system is most applicable only for a deep space mission, and the cost of this ion propellant used is very expensive. And fourth, complex power condition, high voltage. Last, single propellant is used, and last, low thrust per unit area. Now coming on to the conclusion of ion thruster, the propellant choose should be not cause erosion of the thruster to any great degree of permits long life, and should not be contaminate the vehicle. Second, more efficient than the chemical propulsion. The application of ion thruster is electrostatic ion thruster is used in column force. Thank you.